Thanks everyone for joining us today. We're going to be talking about pretty much how to take open source software and essentially turning it into an enterprise ready construct. That's really the focus. And of course, the open source software is Ray. And the environment in which we're going to be deploying it is the Google Cloud environment. So you're an organization that has security controls, networking constraints, as any organization would. So you want to take an open source software and adapt it to an enterprise. What do? So why are we even talking about this? Because we tried to take Ray.io as is and take it into a enterprise, production scale, secure environment. And there were things that we encountered that we thought, hey, maybe this can improve, this rising tide can raise all ships if we share these best practices. So in the QR code that you see here, we've written a blog for you. We like you so much. We've written a blog just for each and every one of you, just released last night for this talk, which basically goes into a lot more detail. Because I have half an hour. I can't do it justice. I'll try to go slow, but you need the detail because this is very practical stuff. So get the QR code. It's up there. Take a look at it. If you have any questions, get back to us. My colleague Balázs Pinter and I, Balázs did the lion's share of the work here. He's a GKE, Google Kubernetes Engine specialist. And him and I were trying to figure out how to get this open source software in an environment that had these constraints. So that's kind of the story. So the background is that if you want to do machine learning on Google Cloud, the Vertex AI platform is what we call our end-to-end soup to nuts platform. You can pre-train models there. We have LLMs there. You have AutoML. You have model registries. You can do training, serving, etc. In fact, you can do pretty much anything on this very robust, very soup to nuts end-to-end platform. But the point is, if you're bringing open source software into an environment that's an enterprise environment, how do you adapt the open source software to conform to the standards? And by the way, although I work for Google, I could be working for any of the hyperscalers and pretty much saying the same thing. I'm just using Google as a case study for this. So in any environment, you take Ray, the open source version, and try to implement it, you're going to encounter some of these issues. So it's like a checklist for you. So on Vertex AI, I don't know, how many of you are interested in generative AI these days? Some? All? It's like, why are you even asking this question, Ali? We're here. We're in the whatever century we're in. We even forgot what century we're in. So basically, what we've done is we've opened up. Google has always been about open source and integrating open source into platforms. We've open sourced things. We invented the word2vec and gave it to everyone, the embeddings. Everybody thinks it's just the transformers that we invented. It's actually word2vec that actually precedes everything on these embeddings. And then the transformer architecture in 2017. In 2018, BERT, the bidirectional encoding representation for transformers. And then T5 and T5 FLAN, the fine-tuned version of FLAN, instruction tune that everybody basically takes and fine-tunes and uses for downstream tasks. But in terms of open source, we actually have a version of Ray on GCP that we've just announced in preview at our conference a couple of weeks ago, right here at the Moscone. And so that's cool. You can run Ray directly there. But this talk is not about that. It is about how to run it open source on a platform. So GKE, the Google Kubernetes Engine, allows you to build your own custom ML platform if you so wish to do so. So Vertex AI is, if you don't want to build everything, all the GORP and all the if you don't want to be your own mechanic in your garage, then use Vertex. If you do want to become the mechanic in the garage, use Kubernetes engine, the Google Kubernetes engine. So it's a managed Kubernetes service that we invented Kubernetes, open sourced it, and it provides a platform for running containerized applications. And you can use GKE to build your own ML platform. A lot of people are doing that. Many of our customers are doing that by deploying the necessary tools and infrastructure that Kubernetes handles for you. Some of these are Kubeflow, MLflow, Ray.io, and Jupyter Notebooks are running on it. Okay, so with that kind of backdrop, we have a series of things that are critically important for enterprises, for production systems. One is enterprise security, topmost. Building your own enterprise platform, ML platform, gives you a lot of flexibility and control over your environment, but honestly, it comes at a price. And it is that you have to manage it. And that can be challenging because there are very strict security requirements that you have to comply with internally and externally from a regulatory perspective. So Ray is an open source software. It offers huge amounts of flexibility, but there are some key considerations we need to address. And this may restrict it if we don't address these things in the full potential of its use in the enterprise environment. So we're going to start with authentication, authorization, and access control policies. So first thing we need to do in implementing OSS in an enterprise environment is to ensure that the open source software is integrated with the enterprise authentication authorization mechanisms. It could be Active Directory, it could be LDAP, it could be Samuel. This is used to authenticate users and control access to resources. Ray doesn't currently have, the open source version doesn't seem to have fine-grained access control built in, so we have to rely on the access controls provided by the infrastructure itself, and we have to make sure that the authorized and authenticated individuals who are accessing it are able to manage the Ray clusters and interact with the Ray endpoints. So if you're in the Google Cloud environment, you use the cloud identity capabilities, private GKE clusters, not the public ones, Cloud IAM, and then Kubernetes RBAC integrated with Cloud IAM, and identity-aware proxy, and a VPC service control. This allows you to integrate Ray's security with your environment in GCP. The second thing is around encryption. We need to ensure that the open source software encryption mechanism, like the SSL, SSH, TLS, are protecting our data in transit. So Google Cloud itself provides encryption at rest and encryption in transit by default, but you need to make sure that when you're actually spinning up these clusters, that those target clusters have these encryption mechanisms enabled. So to do that, you can use a customer-managed encryption keys, external key managers, cloud HSM, load balancing, SSL certificates, confidential compute. And if you're writing an application, you can use this Tink library for application-side encryption. The third one is the vulnerability assessment. You need to perform an assessment of the vulnerability of the open source software and address any holes, any identified vulnerabilities. GCP has container analysis that's integrated with the container registry and the artifact registry. And it also has binary authorization in the security command center. And there are other third-party integrations that you can have. The next thing is patch management. So you need to implement a patch management process to ensure that, because a lot of these security patches are just, they're not there. Next month, one's going to come up. The next week, another security patch comes up. Some vulnerability is detected. You got to keep these patches up to date. So Google regularly patches GKE for known vulnerabilities. This includes both the Kubernetes and the underlying operating system. And we provide an end-to-end container-optimized OS, which is based on Chromium OS, to implement some of these security design principles. So you can use these container optimized OS and Google Secure Base images in order to do this patch management for you. The next one is the segmentation of the network. So you have to segment the network so that you limit exposure. So here's array cluster. You can't have it fully connected with everything else in the enterprise. By default, apparently, it may be. So you actually have to segment this subcluster so it's not essentially interacting with the rest, and essentially avoiding potential attacks from other enterprise systems that some may attack. They may attack a vulnerability in one enterprise system and gain access in another, and then it becomes a problem. So within Kubernetes, you can isolate pods. This is what we recommend you do, and workloads, specifically in a multi-tenant cluster. So you can apply VPC firewall rules, hierarchical firewall policies, and the Kubernetes network policy to actually implement these capabilities. The next one is monitoring and logging. So you would implement monitoring and logging so that if there's a security incident, you can respond to it. You can detect it, you can respond to it, and ensure there's a traceable compliance with security policies. As part of the cloud audit logging, Google Cloud Services actually writes audit logs so that you can answer questions like who did what to what system, and in terms of the resources that you have allocated. And for that, you can access the Google Cloud audit logging capabilities and log exports and retention policies. The next one is just plain old training. The need to train enterprise users on security best practices and policies that are related to open source software. There actually are many certifications that are available, and there are hands-on training labs that you can take. There's something called the so what I recommend you look at is look up the Security Foundation's blueprint, and then there are 2 certifications that you can go through under that. One is the DevOps engineer, one is the security engineer. And then in terms of third-party software, libraries are third-party that are used by the open source. If you recall, remember this thing about Log4j happened a while back? This was because Log4j was using another piece of software. So it's not that that had vulnerability. So it's the reliance of open source on other pieces of software, because they can't build everything from scratch, right? It doesn't make sense. So you want to have this software delivery shield, which is a fully managed end-to-end software supply chain security solution that's offered as a part of Google Cloud. This helps you secure software supply chains on the GKE engine. Okay, so now in this section, we're going to talk about, so up to now, those were kind of generic checklist points for you to take a look at. Here, what we're going to be doing is looking at Ray on GKE in a policy-constrained cloud organization. How exciting is that, right? This is super exciting. So I usually talk about Gen AI, and I usually go into a whole lot of details. But this was something that we just said we had to do this because we encountered this issue ourselves, and we just got to tell people about it. So my previous talk today was, all about Gen AI and how do we, make Gen AI enterprise ready and the enterprise ready for Gen AI and all that, and best practices. And we had a blog on that too, by the way. That's a very cool blog too. I can give you that link as well. But this is important because honestly, without these kinds of security things, using open source software is not always that straightforward and could be a vulnerability. So although it isn't as exciting as what we're usually talking about, we'll get into it. So policy constraints that are applied to virtual machines, and then those are applied to GKE clusters, as the node pools essentially of these clusters are essentially virtual machines. So there are some policy constraint capabilities that are there in the Google Cloud Platform. You can look them up. There is resource location restriction. On the compute engine, there are shielded VMs. You can make sure that there's a required login and restrict non-confidential compute, and so on. Another important aspect of GKE on a policy-constrained organization is the potential VPC firewall restrictions. So GKE by default allows full mesh connectivity within a cluster by creating all the required firewall rules it needs. And these firewall policies may override the project level firewall policy that you put in place that your organization has mandated. So you have to be aware of that, not to get it overridden, because then you're violating your organization's firewall policies. And there are a bunch of complex network topologies that affect how these external resources and API-based services are accessed. There is a rule evaluation order that you need to take into consideration, basically so that when you install GKE and spin up a cluster and give it some rules, it doesn't violate your enterprise rules. The next one are the Kubernetes network policies. The network policies essentially allow very fine-grained configuration of the network access control between pods within a cluster. They can allow or deny traffic to and from the pods. And GKE supports Kubernetes network policies in both the data plane, in both network data plane implementations. So you can enable data plane and the Calico Kubernetes network policy. So that's something you can actually enable. The next one is IAM, basically, to authorize who can, basically access these systems. But the multiple aspects relating to GKE and Kubernetes is around the cluster management, the resource management, and the workload identity. The workload identity specifies a mapping from the service accounts to the Kubernetes service accounts to the Google service accounts, that kind of a mapping. And it allows you to specify which pods in that cluster should be authenticated using the Google service account when communicating with Google services like the data warehouse, BigQuery, or Google Cloud Storage, for example. This is just, I just made this bigger so you can see this on the screen. So this is your project, different service accounts, and different clusters. There is a relationship between the actual service accounts and the Kubernetes service accounts. So that relationship has to be made explicit. When you deploy Ray.io on GKE on Google Cloud, so you can deploy Ray in 3 ways on GCP. Number 1 is on a VM on GCE, Google Compute Engine. Number 2 is on GKE, which we've been talking about primarily, which is the Google Kubernetes Engine. The third one is just Ray on Vertex. So that's the simplest, easiest, But more traditionally, people look at the GKE mechanism here. So you have a number of identity-aware capabilities, potentially the Vertex AI Workbench that you're working on, a notebook, a Jupyter notebook, load balancers, and they are all accessing Kubernetes engine that has the Ray head here in the pod and a bunch of workers. So there's a head and a bunch of workers. And they can then access databases, different service integrations via pub/sub, or data warehouse capabilities like BigQuery, or just share a file system. So in terms of the GKE cluster deployment, you need to create a standard GKE cluster with the cluster autoscaler. And use this, you can find that in the blog and copy it if you need to satisfy these constraints. So there are a whole bunch of things like enabling private nodes, like the workload pool, the boot disk KMS key if you want to do KMS. So these are all different types of things that need to be enabled, especially the private node enabling. Because otherwise, the GKE clusters on Ray will be public, and you don't want that to happen because you're training models there. So the array operator and array cluster. So on kubeRay, because as you know, Ray runs on kubeRay, there's an operator and there's a array cluster deployment. So once the cluster is created, the deployment consists of the following steps. You check out the array repository, you deploy the kubeRay operator, you wait for the operator to get ready. That takes some time to spin up. You create and deploy the array cluster, custom service that matches your requirements, and then you test the deployment. You can expose the array head service using an internal load balancer. This is non-obvious. So you want to actually create a internal load balancer and expose the head cluster via that load balancer. This is not by default happening. So this is how you would get that done. And then you want to expose the dashboard in a secure way so that when you're monitoring the array cluster, you're not giving the IP addresses of all the array instances in your cluster to everyone in the world. So the array dashboard actually has to become private. It has to be secured. And so you use identity-aware proxies, obviously IAM, encryption, and but the provisioning is just the basic GKE out of the box. So you reserve an external IP address, you create a DNS record that points to the address, you configure an OAuth credential, and then you create a backend configuration, and then a managed certificate. Ultimately, you create an ingress that's annotated with the previously created reserved, this first one, step one, this reserved IP address, and the managed certificate that you had. This is how you would expose the dashboard in a secure way. You're like, why is he going into all this detail? Because if you don't, your dashboard is going to be exposed, and you don't want that. And obviously, you're not going to remember all these things. That's why we've written it down for you, so that later on you'll know, hey, I have a dashboard. It's going to get exposed. I got to protect it. OK, how do you do that? You're going to look it up and then copy the code and change some things to accommodate your environment and get it set up. So this is exposing the dashboard in a secure way. So you choose an account to continue, for example, and then there is a HTTP request that comes in from the sign-in, bless you. The user uses Cloud IAP to authenticate and authorize roles and permissions. You have the firewall for the compute engine and Kubernetes engine. That was from 5 slides before. I'm making it up. I have no idea how many slides before. I'm just checking if you're awake still. So we talked about the fact that there are two, seriously, the key important thing here is that there are two firewalls. One is just for the compute engine. One is for Kubernetes. And then remember, there was a service account issue with your personal, or the service, Google service account and the Kubernetes service account. If you only remember that dichotomy of those two things, and then you look it up, and this is why you've come here to remember these types of things. And then access your app via a virtual machine capability from that firewall. So this is what it would look like in terms of the dashboard. OK, very good. And this is the blog. If you want to look it up, it's here. And I know you have detailed questions to ask about the configurations. Happy to answer them. Or if you want to talk about other related array capabilities, I'm happy to do that as well. Let me bring up this other, this is the other one if you want to look at it. This is the other thank you. This is blog number 2. This is the Gen AI one, which talks about a whole bunch of other additional cool stuff like this. OK, any questions? So if you're going to remember a few things, number 1 is make sure you go through this checklist before you deploy it in an enterprise setting. That's basically what you need to do. And then there's going to be dichotomies. Service accounts, Kubernetes service accounts. IAMs, internal, external. Exposing the dashboard. No, don't expose the dashboard. Put it behind a secure dashboard. Access to the head node needs to be secure as a jump host, as a load balancer. So these are details. You'll probably evaporate from your brain, but a few of these are enough to make things secure for you. All right, awesome. Any questions? Very good. Excellent. You have all been certified. Yes, go ahead.
Yes, so you mentioned that access to head node must be secured So access to head node must be secured through the load balancer, right?
It's one option. One option.
Yeah, I just wanted to clarify here. So since head node can be only one, it's a single node, right? Then we don't really need to balance load here.
Exactly. It's not the load balancing capability. It's the characteristics that come along with being a load balancer, like access to the jump host, like all the security that is, because the head node, to your point, we don't really need to load balance the head node. Yeah. Your point is exactly well taken. It's just the other capabilities that comes with being a load balancer that would be retrieved. Exactly. Someone was listening here. Thank you.
Like a reverse proxy.
Like a reverse proxy. Okay. Exactly. Okay. Yeah. Brilliant. Yes. Thank you for that. That brought things to light. Thank you. Yes, sir.
When I was listening to the keynote, there was a big mention of private endpoints and inference. From what I understand from this talk is mainly this for training or can also be used for inference?
Potentially, this talk is about setting up the RAID cluster. So then you could do either on it. Excellent point, though. Yes.
Thank you.
It's just really infrastructure oriented on how you set up security around that. Yes. And then you use the magic of RAID to do all these other things. Yes. Awesome. Thank you, everyone. Appreciate it.